All right, it's recording. So, exercise 11A is not anti-diff in any way. It's actually just finding the area under a curve using some sort of method to estimate for it. Now, there are three methods, two of which was been around for ages, and then the third one came in probably 2018 or so. So, the third one has been on the exams, and it's worthwhile learning. That third one's on your syllabus now, or your study design. Three methods. You've got your left end. So you need to know how to do it left end way. Right end method. And then you've got the trapezium. In the States, I believe they even learn the average between the two. I think they call it the midpoint or the average. But I'm going to show you it anyway, just so you have an idea of how it works. So, this is the theory. The idea is that when it comes to a curve, finding that area under a curve is much harder than, say, if I just gave you a linear graph like this. So let's say y equals x. And between 0 and 2, for example, if I asked you what is the area under this curve, the nice thing is geometrically, it's a triangle. So you can work out half times base times height, or you get a rectangle and then halve it, right? So you can get the area. The problem arises when you have a curve where it's continuously just slightly less. So if you draw a rectangle, there's always going to be a bit left over. But how you draw those rectangles matter. And this is what they were saying. They were saying, all right, well, if we made rectangles, so let's say a curve, if I drew a curve that looked like this, and yes, let's say between 1 and 2, and I want to know the area under these two. If I drew only one rectangle, so let's say from here to here, so this is the right end point. I'm using that right end part of the curve. So from that point, that gives me the highest point. And I've got a rectangle. This rectangle is too much of an estimate. Okay, I'm overestimating the actual area. But then if I use the left end point, so let's say from number 1, that gives me this height. That's now 2 under. So what they then say is like, well, that's one rectangle. I'm losing too much of an area. What if I made the width of the rectangle smaller? So they're saying the width is currently 2 minus 1. Or in their terms, they say B, and that's A. So the difference must be B minus A. But then if you divide them by the number of rectangles you can get, theoretically, I'm trying to teach. Whatever you guys are doing right now is not beneficial to me. So to make the rectangle smaller, we need to divide it by a larger value. But the larger the value you divide, then that means the more rectangles you get. The more rectangles you get, the thinner the problem is. So it can be like that to like that to like that. And you can see that you get a better estimate of the area under the curve, but there'll always be slightly off. So in a theoretical sense, kind of like the derivatives, if n approaches infinity, then you'll get smaller and smaller and smaller, then it gets even closer to the approximate or the exact area under the curve. But there are two ways of doing it, and that's what you're going to learn first. So left end, right end, and then the trapezium. So here, this is what we're going to learn. Let's fill in the points here. So you've got the left end point means when you start from 2 to 5, from 2 to 5, that 2 will create a point on the curve, and you will use a rectangle that is on the left-hand side. Okay, so that point represents the left-hand side of the rectangle. If it was a right-end estimate, then you wouldn't use that point. You would actually use the next point as your right point. Okay, so that's the difference between the two. One's a left, and in this case, it's going to be an over an estimate. But if I use the right end, you can see here, I don't take the 2, but I take the next part of the rectangle and I find the height. That's your f of 2.5. And that gives you this rectangle now. So this is called a right-end estimate when I'm using the right hand of the rectangle to make the y value or the length of the curve, okay, or the height of the rectangle. Out of the two, the top left corner of each rectangle, this is the formula to describe it. As you can see here, this is b minus a talks about the width of interval that you're interested in. N is the number of rectangles you want to make, times by, now notice here, f of x0, f of x1 plus all the way f of whatever n is, n minus 1. That represents the y values. Because the first one, you actually take the first value. So if it's at 2, you do take f of 2 times by the width. That's the width. That tells you the width. Times length. Plus the width. Times length again. Times width. Times length. That's why it's x0, x1, x2, all the way to xn minus 1. Because it's always one less in the final. Whereas in the right n estimate, you can see it's the other way. We don't use the first one. We use x1 because it's the right one. But that also means you use the end point, which is xn. Okay? So that's what the formula is. And the reason why I'm getting you to focus on the formula is because the trapezium rule, I know it's in your formula sheet, but when it comes to pseudocoding in your multiple choice, I think students struggle to understand that process. So it's not that you don't understand how to do it. Intuitively, it makes sense, but it's reading the equation so that you know what the question's asking. So often, so far I've seen, it's more of a trapezium rule. So get familiar with the trapezium rule. In the part of the exercise is really just to get you to practice doing left end estimate, and then right end estimate, and then find the average between the two, because if you find the average, it's closer to the actual area minus the errors. So here, if you fill them in, it's top right and top left corner. Key things to note is the first y value and the last y value, between the difference between the right end and left end. Okay? Trapezium rule is meant to be a better estimate. So with the same graph, with the same number of rectangles, I want you to have a look at the graph here. It looks much better. It's not perfect, but it is much better estimate. Okay? And it doesn't have an oversight and it doesn't have an undersight as much. So technically, we do say that the trapezium estimate is the average of the left end and the right end estimates there. Okay? The larger the number of rectangles, the more accurate the estimate is. Okay? So the larger end, the better. Right? Means more calculations. Now, this is the formula I want you to familiarize yourself with. Or if you understand it intuitively, you understand why it works the way it does. Can someone explain to me, because we're looking for the area of a trapezium, right? Why are these twos up until except for the last and the first? Because the trapezium rule, the area of a trapezium rule, if you've forgotten, area of a trapezium rule is half times a plus b times the height. So if you look at each shape, that's a trapezium. So if I zoom in, here's your trapezium. Actually, I'll do it another color so it's more obvious. So 1 point, second point. Here we go. We got a trapezium going on. So if I drew it a bit more clearly, this is what we have. That's your trapezium. Area of a trapezium is half of a plus b times height. Now let's just break things apart. What's a plus b? Which one's my a plus b in this trapezium? Two parallel lines. So here, when you're looking at these trapeziums, they're actually flipped vertically. These are my two parallel lines, A and B. So it makes sense that I add whatever height of f of 2 is, and then height of f of 2.5, right? That gives me these two. Times our height. What would be the height? Based on the graph, what would the height be? So this is clearly f of 2. This is f of 2.5. So that's my... So that's 2, that's 2.5. Which one's my height?
2. Or f of 2, sorry.
Not f of 2. F of 2 is this length.
Wait, no.
That's the y value.
F of 2 is the segment distance.
So which one's my height? Yeah. So you're right. These two is your f of 2 is your A and f of 2.5 is your B. Then which one's H? If this is f of 2, this is f of 2.5. Which one's my h?
Is it them added together and divided by 2?
Well, you're right. It is all of them divided by 2 because of the half here. But I'm sort of asking for the area of a trapezium. We've always known that it's a plus b, and then you've got to times it by the height, right? So where's the height? How would you normally find the area of a trapezium? Yeah, it's the width. It's this one. You know how when you find a trapezium, usually it looks like this? Like that? That's your trapezium. So you'd say a plus b times height. In this case, we've just flipped it around. Your height is here. That's your height. Right? So if this is your height, that's your a plus b, that's your two parallel lines. That's your height. That height represents the width of each rectangle. Right? And the width of each rectangle can be found right here. So in another way, what I'm trying to say is this is that. That is the width of each rectangle. The half is right here. So what I'm asking now is, can you explain to me why then, if this is a plus b, and I said be careful, why is this doubled, except for the first and the last one? Does anyone see it?
So there's always two of the ones in between. So you've got like the first one, and then f of like the second line in. There's going to be one for one equation and one for the other. So it's like a shared line.
That's right.
It's used in both equations.
Beautiful. Can you guys see that? So if we were to find the area of this trapezium, you would have said half times the width, but the width is all the same. So height is always going to be the same. Half, you're always going to half it, but you're always going to do a plus b. But notice the a and b, this is a, you only add once with this one. But then in the second trapezium, you do it again. You do b plus this one. So that's why b doubles up. This one then doubles up. All the ones in between double up except for the first and the last one. That's why your rule has the 2. Now that rule is already in your formula sheet, but that explanation there that I'm trying to get you to see, the examiners want to test that. They'll be looking at, they'll give you a pseudocode that you have to read through to understand that bit of the theory. Okay, so when they're finding the estimate, that's what they're wanting to test. Do you know how the trapezium rule works? Can you interpret how the rule actually works as well? And then they give you a multiple choice usually. Okay, I haven't seen it much as a short answer, although it can be. It's pretty doable to do it as a short answer question. All right, let's do a practice. Now, I gave you a link in this sheet here, and I find it useful for you to visualize what's happening. But this question here, find the sum of the areas of the shaded trapeziums to approximate the area under the graph. And here's your graph. I've given you the picture of the graph. Between 0 and 3. So between 0 and 3, 0 and 3, how many rectangles do we have here? We've got 1, 2, 3, oh, sorry, not rectangles, trapezium. 1, 2, 3, 4, 5, 6. So if you want to know what the width of each trapezium is, it is B minus A divided by 6. Now B, our limit is 3. Initial start is 0, so each one should be a width of half. So each one is half, so hence why it's 0 to 0.5. So half, 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 half. Now if you were to find the area of each one manually and by hand, how would you do it? Here we go. You need to find the first trapezium. This is A, this is B. You need to find f of 0 plus this one is f of 0.5. But then you'll find that if you do the second one, so I'm going to do it in a different color now. If you're going to do the second trapezium, see I'm using B again. I'm using B again, and it's f of 0.5 plus f of 1. That's why it doubles up. Okay, so that f of 0.5 doubles up. So you can do it all in one go, following the formula that I've given. up here, we can actually follow the formula and say, well, it's half. This is times the height, and this is your ABs, all the ABs put together. So you're finding, at the moment, f of 0 plus 2 times f of 0.5, because I know each width is half, plus 2 times f of 1, plus 2 times f of 1.5, all the way up until you get to the last one. I'll do the last two. So it should be 2 times f of 2.5 plus f of 3. Does that make sense of what I'm doing there? Because that's pretty much today's lesson. It's about you getting that component. The second part is whether you can draw left end and right end. I think theoretically most students get it, but when they're actually trying to do a left end, right end, sometimes you get confused how to draw the rectangles. I think that's part of the lesson. Okay, so part of the lesson is working the exercise so that you can draw a left end estimate and then a right end estimate, and then you can find it by hand. So if it's in exam 1, you can do it by hand. Exam 2, it's a plug and play. So I've already plugged in on my calculator. If you've done it correctly, you should get 35.84 as your area. Okay. Copy that down just so that you've got the area, and then you can test if you've got that right for the first one. The second example, which is the last one for today, I want you to have a go at drawing the left end rectangles and the right end rectangles for the width. I think it was from 1 to 4. So if you flip over, there's 3 scenarios there. So I believe in the US, you also have to draw the midpoint one. So I'm going to show you how to do left end, right end, and then do their midpoint version. Okay, so if you're ready, flip over, or not flip over, have a look at this second example. I only want you to draw the left end and the right end estimates from 1 to 4. So 1 to 4, 1 to 4, 1 to 4. I want you to do left end first, right end second. And for those who are a bit savvy, see if you can figure out how to do the average of those two visually. We can do it algebraically, but how would you do it visually? What would it look like as an average point? Let's have a go. I'm going to give you, let's make it 5 minutes. It's 2:25, 2:30. We'll wrap it up with the answers, and then I'll show you with the Desmos link. It's pretty nice to visualize what's happening. So you get to see all 4 techniques: left end, right end, average, and trapezium rule as well. Here we go. The Desmos link I gave to you. Eyes near towards the board. Thanks, team. That link, that will take you to this Desmos one, and I like it. I found it on Desmos. It's really useful. You can type in the function that we're in. So we've got x times 4 minus x. So here's your function. You can change the interval, so A and B. I already have it 1 to 4 ready for you. And you can also change the number of rectangles. Since I know the number of rectangles is 3, I just typed in 3, so it works out the width for you and all that, right? But what's cool is you can choose right end, left end, midpoint, which is the average, or the trapezium method. So you can visualize what it looks like, and as you change, get your head around it. So let's see if you've done it right for the left end estimate. Starting from the left, your shape should look something like this. Have a look, because I'm going to go back to the actual shape, and I'll focus on where it's meant to be. So left end estimate, you start with the first one, so x0. So if you start with the first one, that's the left side of the rectangle, so you should be able to connect it and then continue on. So if you continue on, it's always the left point that touches. It's always the left point. So that's how I get my left-hand point. So I'm always focused on the actual point that touches the curve on the left side of the rectangle. Okay? Whereas in the right-hand estimate, you don't take the first one, you take the second one. So x1 is this one. So that's the right-hand side. So when you draw it, this should be the point for the right-hand side of the rectangle. So if you draw it out, that's how you get your first rectangle, and it's the right-hand estimate. And then you follow the same. So the next one is from here. That's the right end of the rectangle. And then same thing, this is the right end. There should be nothing there. So if I go back to this one and I typed right end, take this off, that's what it looks like. So you should have the right from the second point, and then it goes down, and then it's 0. Hands up if you got those two correct to begin with. All right, good. And then now let's find the area of each one. Since the width is 1, they're all width of 1. Height is pretty easy to see. It's clearly 3. So this one is 1 times 3. You got 3. Plus 4 times 1 is 4. Plus 3 again. So in total, the area should be 10 units squared or squared units. Did you guys get 10 squared units? Yes? Okay, good. Next one. Width of 1. This one's height of 4. So 4 times 1 is 4. This is 3. So 3 times 1 is 3. And then this one's 0 height. So that's area of 0. So if you find the area, it should be 4 plus 3, 7 squared units. Which makes sense. It's an underestimate whilst the other one's an overestimate. So far, so good? Last one. So in the US, we find the midpoint or the average. This is how you find it. Average means that for each interval, instead of taking 3, and instead of taking 4 for the first rectangle, we find the midpoint between the two. So for the first rectangle, one had 4 as your height, the other one had 3. So the average of 4 and 3 is 3.5. That's where your actual height of the rectangle should be. So right here is the height of your rectangle. Then you do the same for the next one. Next one has a height for the second interval, has a height of 3, but this one has a height of 4. So that means your second rectangle should also still have a height of 3.5. So you see the difference? So I'm just following this second rectangle, 3 and the 4, found the average, so it's 3.5, 3.5. And the last one, this one has a height of 0, this one has a height of 3. So midpoint of 3 and 0 is 1.5, which is here. So 1.5 is there. So that means I need to hit this point of the curve. So you should expect a graph for the mid to have 2 bars that are exactly the same height and then one that's a bit over. So if I now do the mid estimate, that's what it looks like. Okay, 2 bars that are the same, one that's 1.5 and out. Now remember, this is not part of the syllabus. I just thought I'd show you it's the average, and that should be a better estimate of the actual area than just the left end or right end. Okay? If you did the trapezium rule, it actually should be closer to that one. And on the Desmos, it's pretty cool. You can also do it too. So you can get the trapezium there too. Okay? Yeah, I know. It looks pretty cool. So trapezium rule is the main thing. So what's the lesson to take out? Can you sketch left end, right end? And can you do trapezium rule and identify the parts, how the rule works? That's pretty much 11A. So that's an intro to chapter 11. The rest is your session. And next week, that's when we get into anti-diff and definite, indefinite integrals. Okay? We'll stop there.